you guys to recognize here is that we have a cube term plus another cube term. So it's just like the sum here, right? Now, if we have cube term plus cube term, notice my first expression is a. Here's a cubed. Here's a. That means a is the cube root of a cubed. Would you guys agree with me? OK, so if I want to find the zeros, first thing I'll do is I'll set this equal to 0. Here, the cube root of x cubed then is just x. Cube root of 27 is 3. Therefore, then this can become x squared minus 3x plus 9, right? Because 3, and then this is b, and then that's b squared. OK? Yes?
So when you have it was x, a is x and b is 3. Why would you put, when you put a, b, you would just put the 3 in front of the x and then do the same thing for this equation?
Yeah, I'm just putting, instead of x. Yeah, I mean, 2 times 3 is the same as 3 times 2, okay. Right? All right, now, do we have this in linear factorization form? No, but this one is, so I can find 1, 0. You know, x plus 3 equals 0, x equals negative 3. Cool. This one, I'm going to set equal to 0, but I can't, let's try to factor this. What two numbers multiply to give you 9, add to give you negative 3? Uh-oh, it's not factorable. Crap. If it's non-factorable, I could either complete the square, or I could use the quadratic formula. Well, I don't really want to complete the square, because that's going to give me a fraction. So I'm just going to use the quadratic formula. And again, this was on your quiz, if you knew it or you didn't, because remember, I'm not going to tell you. If you didn't know, then obviously. But there was a problem that was non-factorable on your quiz. So therefore, you had to intuitively go into using the quadratic formula. So here's the quadratic formula. I need to solve this. I got to find the zeros. It's non-factorable. So therefore, I'll say x equals, which is going to be my solutions, x equals opposite of b, which is going to be positive 3, plus or minus the square root of negative 3 squared, minus 4 times a times c, all over 2 times a, which is 1. So x equals 3 plus or minus the square root of 9 minus 36 all over 2. Let's go ahead and simplify this a whole bunch of times. 3 plus or minus the square root of negative 27 over 2. Remember, guys, negative, I can automatically take the negative out and treat that as like an I, right? And then I could also make this look like this. 3 plus or minus, let's do I. And then are you guys OK with me breaking up 27 as 9 times 3? Is that OK? There's nothing wrong with that, right? But that's helpful because can I take the square root of 9 now? Yeah. Yes, I can. So I'm actually going to go back here. So we could say x equals, I'm showing you guys step by step by step. But obviously, that's because I haven't really gone through this in much detail yet in this class. But in reality, you guys could probably skip a whole bunch of steps here. So therefore, my answer is 3/2 plus or minus I 3 square root of 3 over 2. Whew. So, but let's double check. I have one real 0. And then how many imaginary zeros do I have, or complex? 2. We're looking good, right?
Wait, is that?
It's plus or minus.
Oh, OK, I thought that 3.
Oh, I should have wrote the I back. It should be 3. Usually like doing that. Now, if I wanted to write this in linear factorization form, linear factorization, really? Well, think about it. Yeah, I mean, guys, if I have x, let's just do one of them. X equals 3/2 plus 3i square root of 3 over 2. If I want to get these to equal 0, I'm just going to subtract the 3/2. So it's x minus 3/2 equals plus 3i square root of 2, or square root of 3 over 2. And then what do I got to do to get that equal to 0? I just got to subtract that on both sides, right? So I mean, it looks crazy because there's like so many numbers. But if you're going to write the linear factorization, or if I said, hey, give me the linear factorization, you would have x plus 3 times x minus 3/2 minus 3i square root of, why do I keep on writing square root of 3? Square root of 3 over 2, comma, x minus 3/2 plus 3i square root of 3 over 2. Okay, that's not like the essential thing, guys, that you're going to have to be writing